So today I'm here to share with you a problem. This is a problem that has been put forth in front of my team and myself, and has been made known to me and the engineering tools team at Netflix, that this is something that's paramount to Netflix's future. It's a problem that impacts every single engineer at Netflix. And the reality is, it's a problem that probably affects you. A lot of you, I know a lot of the companies here have taken steps to solve this problem. But this is a problem that affects every single engineer at any company at any scale, or even if you're just working by yourself. And the disappointing thing about this talk is, I don't think I really have the answer. I know, right? Very disappointing. The truth is, we have a direction. We have a path, a hypothesis of where we're going to go, and how we're going to go about at least alleviating the pain of this problem. And we have a pretty good hunch that this is going to be fruitful. So you might be wondering what the problem is. And the problem comes down to two simple words: shared code. And this is a problem that I think, like I said, impacts everyone, and in ways that you may be aware of and may not be aware of. And so I'm going to talk a little bit about how this impacts Netflix in particular, and I'm going to try as much as possible to apply it to generic use cases. But to do that, I want to talk a little bit about Netflix in particular. Now, if you've been to Gradle Summit in previous years, you've heard a lot about Netflix, and so I won't bore you with all the details, but I think there's two key concepts to understand about Netflix's architecture, and that is we're microservices in the cloud. In both of these instances, in moving into the cloud and moving to microservices, we did this very early on. Probably 2007, 2008 is when we started these endeavors, and this was before many companies were going in these directions at scale. And so as a result of these migrations, we paid the pioneering tax of doing so. We learned a lot of painful lessons about going into the cloud. We learned a lot of painful lessons about building microservices at scale. And as we learned these lessons, we turned these into frameworks. And as we built these frameworks, we open sourced them. And so a lot of the reasons my team and I'm here today is because we've built open source frameworks to solve problems, not only in the build space, but around microservices, resilient services at scale, running in the cloud. And so a lot of you are familiar with Netflix OSS. But Netflix OSS is just an example of shared code, right? These are frameworks that we want everyone at Netflix to use when they build their service. Now, something more familiar, if a Netflix engineer wants to build a service, they might do something like this. So this is, most of you are familiar with the dependency block within Gradle. And what I'm showing here is 5 Netflix libraries: Archaeus, Ribbon, 2 libraries of Ribbon, Hystrix, and Eureka. Now, these are frameworks that we believe, or tools, open source tools that we believe every single engineer should build into their service to ensure that it is a well-behaving service at Netflix. So this is how they would include it at build time, and it's, most of you know that that's pretty simple. But there's another concept that I want to introduce to you that is very prevalent at Netflix, which is this concept of client libraries. And so what I mean by that is, when 2 services are talking at Netflix, we're not exposing necessarily REST HTTP endpoints that communicate and transport JSON. The way you would communicate with the service that I built is you would ask me, what's the name of my client jar? And I would tell you the coordinates, and you would download that into your project, and that would be your API into my service. Now, the reason we do that is I can add in there all the business logic I want to, or as little business logic as I want to, but I can also remove all of these libraries, the necessary libraries that are needed for you to call my service. So in this case right here, I'm including the foobar client, and I'm pulling out, I can now remove all 5 of these other libraries because of a very simple concept called transitive dependencies. Now, most of you might be saying, okay, this guy's up here talking on a keynote about transitive dependencies, but I think this is key to understanding that some of the challenges of sharing code at scale. So the advantage for me as a consumer of this library, this foobar client, is now I can pull in this client and I don't have to worry about all the other library versions that that client depends on. So transitive dependencies allow me to be a little more productive and think a lot less about all the different dependencies. And this makes consuming libraries easy, right? How many people think I'm lying to you right now? smart people. It's a trap. So the problem with this statement is that there's one flaw here, which is software isn't static. And what I mean by that is that library is going to evolve and change over time. It's going to update its dependencies, and I'm going to have to figure out how I'm going to keep up to date with that library. And the approach that the industry has kind of fallen into is this concept of semantic versioning. And so what I, as a consumer of this library, and I'm going to lean on the version number to determine which one I should grab. So if we fast forward, we've worked on this project for 6 months, and or we haven't touched this project for 6 months, and we go back to this project and say, hey, we're still pinning to version 3.1.13 of this client library. Maybe we should update it. And so we go into Artifactory or Nexus or whatever you're using, and you go look to see what versions are available. And you get a list, something like this. And so you can see we're pinning to 3.1.13 up there, and you can see that this team's been active. There's new versions of this client library. There's a whole bunch on the 3.1 track. There's a whole bunch of 3.2. And then also there's this 4.0 release candidate out there. And so the first question we ask ourselves when we look at this is, which of these versions is the good one, right? How many people know which version is the right one if we go back? It's also a trap. So we'll go with latest. We'll go with that. So I'll just say I believe in semantic versioning. 3.1 is 3.plus is what I'm going to use. And so now every time I build, I'm going to grab 3.plus. I'm happy, the team's happy, we move on, we run our build, and then I hear footsteps running down the hallway, and then someone comes by and says, oh, by the way, I heard you're building your project again for the first time in 6 months. You should not use the latest version of our client library. And you go, what? And they say, well, this is the reason. So the version you're using has a security vulnerability. Then the next version has a performance degradation, and then blah, 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 blah. 3.2.3, we just released yesterday, and we found out it actually has a security hole. So you can't use that version. So you maybe should pin on 3.2.2. You could pin on 3.1.16, but we recommend 3.2.2. And oh, by the way, when you're done with this release, could you try 4.0.release candidate 1? Because we're looking for some beta testers to test in production. So you decide, OK, great. I'll just pin to 3.2.2, and I'll be happy. And you learn this lesson very early on, and this is not some fabricated story. This is a lesson that happens a lot at Netflix for consumers of client libraries, is that you really can't trust semantic versioning, or rather, semantic versioning is really insufficient to convey the current state of that library. Semantic versioning's value is really about the intent at the time that someone released it and what the potential impact is. So I think it's going to impact you in this way, but time moves on and things happen. And so you are left with this kind of uneasy feeling that you no longer can trust all the version numbers. But you're a developer and you move on. And you decide to use this library called guava. So guava, you decide to pin on guava 19. And you write some code, and you're pretty happy with your code, and you deploy to production, and everything's great. And then time goes on, and then you hear about this new service at Netflix called the Awesome Service. And you say, I gotta include the data from the Awesome Service. And so you add the Awesome client. And you can see by the semantic versioning that it's telling you that it's kind of new, but it's 1.0, so you're fine. And then you run your build, and it does what is actually not a bad thing, which is it blows up fantastically, right? Your code starts failing compilation, nothing works. And so you wonder what the heck went on, what's going on. It's all failing because of guava. So the question I want to ask you guys is, which version of guava will you get by adding in the awesome client 1.0.5? Does anyone want to take a guess? What's that? 20? The answer is by looking at this, you don't know, right? Because the real dependency graph looks like this. And this is a very simplified version, but you're pinning down to guava 19, the awesome client brought in guava 22, and the foobar client brought in guava 18, right? And what you didn't know at the time is that you were actually already upgrading the foobar client to guava 19, but somehow it worked in production, but you never knew that. And we only found out because you upgraded to guava 22 because of the awesome client. Now, some people in this room might say, well, so what ended up happening is Gradle upgraded you to 22. Now you might think, and I've said this to my team, and they've told me I'm wrong, well, this violates the law of least surprises. I asked for Guava 19, I should be getting Guava 19. And that's the Maven approach to conflict resolution. And the answer is both are arguably wrong, because what ends up happening is either way, I'm getting a version of Awesome Client and a version of Foobar Client that are going to be using a version of Guava in production that it wasn't tested for. So you're just kind of hoping it works, right? So as a consumer of libraries, you're forced to resolve and make decisions about the compatibility of software running on your service. But you have to move on. You have to make a decision. And so you do. And so we have a resolution strategy here to force to Guava 19 because you really decided you don't want to get upgraded to Guava 22. And you build, and for whatever reason it works, and you move on. Now, this in itself is a problem because what this ends up being is technical debt. And this is because what ends up happening is you pin to 19, you move on. Maybe you decided to move on to another project. Another 6 months passes by, new engineer comes on and says, why are we pinning to Guava 19, right? And their question is, they don't know the context behind that decision, why it was made, and also, more importantly, they don't know when it's safe to upgrade to Guava 20, 22, 21. There's not enough information or metadata available to them to make a decision, and as I think someone on my team pointed out, there's no life cycle to manage the pinning of dependencies. So pinning the versions actually results in technical debt. All of this to say that at the end of the day, I, as a consumer of this library, I just want to get a version that works. I don't really care at the end of the day. I just want all my versions to just work. And so we're left with this thought as a consumer of libraries that consuming libraries is very hard. And, but we also think we're optimistic. At least publishing libraries is easy, right? Anyone believe me on this one? Yeah. Nadav believes me. OK, cool. So the first challenge if I own a library and I'm publishing at Netflix or anywhere, is I have to figure out semantic versioning not as a consumer but as a publisher, right? And so I have a pretty easy choice. If it's a bug fix, I'm just going to increment the patch release. I'm going to, if it's a behavior change, maybe I'll do a minor release, and if it's a big API change, I'll change the major version. But what if I'm fixing a bug and it required me to upgrade Guava to 22? Is that a bug fix? Is that a patch? Is that a major release? I'm changing my API. So even this is a hard decision to make because you really actually, especially when you're changing your transit dependencies, you don't know the impact you're going to have on the people downstream. And so that's actually the second question you have as a publisher. I'm about to make a change to my library. Who am I going to break? So this is a pretty hard question to answer in most organizations. In fact, what I found at Netflix in particular is who's even consuming my library is tough to know. What oftentimes happens is I build a service. I know that there's three teams that are looking to use my service. I work with them. I release the service. They have the client jar. I know they're using it. As I upgrade, I'm communicating with them. What I didn't know is that they said, my service is awesome, of course, and that they communicated with 6 other people, and now there's 20 teams at Netflix that are using my library, and I only knew of 3. And so this happens a lot. And then you have another question, which is, I want to change an API. Who do I even know is using this API, right? Because what's the impact of me changing the API? And I've seen teams at Netflix just kind of freeze up during this process and say, oh, we're not going to change the API. We'll deal with it. So as a publisher, you lack this organization-wide visibility. You lack this ability to say, how am I able to, what's the impact of my change across the company? This is a pretty depressing talk already, right? Yeah. But don't worry, there's solutions out there. I have a couple options to solve all our problems. The first one is just deal with the pain. And I put this one up here because this is what we're doing right now, arguably. A lot of organizations just deal with this pain. And you might argue this is a reasonable answer. This is pain, but maybe it's not the biggest problem that you have in front of you. But we're past that point as an organization, so we're moving on to another solution. So as we explore other solutions, there's another one out there that has been popularized by the microservice movement, which is share nothing. Don't share. I start off this talk saying shared code is the enemy, so just don't share any code. And I don't think this is realistic. In fact, I think when people talk about this, they probably mean share little, just a little bit of code, as little as possible. I think this promotes bad practices in software development. I think this is something that I wouldn't even consider promoting in my organization. I do think share less and be cognizant of the dependencies, your dependency graph, and the impact you have on downstream consumers is extremely valuable. But to promote the copy and pasting of code throughout your organization because you want to reuse something is just bad practice. So there is a third option. How many people have heard of the monorepo? Clear case. Oh boy. How many people are currently using a monorepo? Okay. So the monorepo is a solution that was popularized arguably by Google, and they've been doing it for 10, 15 years. And the monorepo has a lot of attributes, some of which I'll touch on. But the idea behind the monorepo is that all of your source code for all of your libraries and all your applications is in one single source repository. That all integration between your projects happens at the source level, so that you're not pulling in binaries. And everything I described before, and everything we do in Gradle is about binary integration, but you're doing source level integration. That your production, whatever is in production is on head or master, which means that you can look at the master or head and the main line of your source repository, and everything there you can be sure it is in production. That there's no concept of version numbers because everything's in head and production. When you make an API change, I can make an API change to my API as well as every single piece of code in the company that's making a call to my API in one commit. So commit those changes, those types of API changes can be atomic. And deployments go out across the board in lockstep. So all those deployments are actually atomic as well. So this is the model in which Google has built, and they've scaled up over years, and a lot of companies have also adopted that based on, I would argue, Google's leadership here. And so this is a viable solution. This solution was built around the concept of the pain that I just talked about around consuming dependencies and sharing code. And Google has proven that it can work at scale. So, and I think it's a very viable option for anyone considering these problems. But it's not without its problems and its constraints. And there are some things written about it. Few companies have tried it. But the biggest constraint I see is that the monorepo is built around this concept of gates and when you push code up into production. So if you talk to anyone who's been building a monorepo organization, you hear them talking about that when I make a change, it has to go through code review, it has to go through build, it has to go through test, and there are gates for me to get my code into production. Now, a lot of you might think that's a good thing, that there's checks and balances for me to release my code. This works fine, and it depends on your culture and your organization. For Netflix, we have a culture built around freedom and responsibility. And so we see these concepts of gates and restraints and kind of this lack of trust, innate trust, as antithetical to our culture. And I see that as a huge barrier to even adopting and considering Netflix. And so we're left with this problem, which is I've outlined 3 options: a monorepo, deal with the pain, and share little. And I'm basically talked myself out of all 3 of those. So what is this approach that we are taking? And so my team and I, we've talked a lot about kind of the challenges here. And we came up with an approach, or at least a flag on the hill that we're moving towards, which is, can we get the benefits of a monorepo without the constraints? Can we move to a world where we can get all the advantages of having that the monorepo tries to solve, but without switching all of our development processes, without switching all of the tooling we have? Can we use the existing tooling and augment them and enhance them? And so that's kind of the direction we're moving into, and I want to talk about that approach right now. And our approach comes down to 3 things. publisher feedback, managed source, and distributed refactoring. And I'm going to talk about each one of these things. So the first one is this idea of publisher feedback. So if we go back to the challenges of publisher, I don't know who I'm going to break. I don't know who's consuming my libraries. This is a huge obstacle to being an effective publisher of code and communicating at Netflix or at any organization. So what we've done internally is we built two tools that complement each other. One is Astrid and one is Niagara. The idea behind Astrid is that Astrid gains complete understanding of the dependency graph at Netflix. So in order for it can help me answer the question, who depends on me? So if I release a library, I can say, hey, Astrid, who's using this version of my library in production right now? And it can give me an answer via an API call. And usually, we built this originally thinking we wanted a universal kind of almost a SQL for our graph. But we realized what we really needed is the only time ever people ask these questions is to take some action. I want to know who's using this library, version of the library, so I can tell them to stop using it. If we go back to our example of I've published something bad in production. Niagara was built around this concept of I want to give you feedback on a library you just published. Imagine I've published a candidate version of a library. I want to know who's going to break with that version of the library. So Niagara's job is to do that. And so the way they work together is something like this. We take a jar file and we publish that jar file. Owner of a library would publish that jar file in an Artifactory using Gradle. And Astrid would be inspecting and monitoring constantly the artifacts being published in an Artifactory. And Niagara would see this publish event, and it would trigger, and it would ask Astrid, hey, Mike's team just released a library. Who's going to pick it up? And Astrid would return back a list of projects. And then what Niagara would do is turn to our container cloud called Titus and say, I want you to spin up a container per project, do a git checkout, and then run a build with the new version of the library that Mike just built, or Mike just released. And then if it fails, run a previous version so we can detect some regression. So I actually want to make sure that I'm not just breaking projects. I want to know, did this project actually regress? And did Mike's release introduce a regression? And then give me an aggregated report of what happened with that release. So Niagara's job is to really build everything after an event, a publish event, and give the owners of that library this nice report. An example of a report looks something like this. So in this case, we found 89 total consumers of this library. So there's 89 projects at Netflix that would build. 53 of them were successful, so we didn't break them. One of them failed. One of them broke in some way. And for various reasons, we've excluded 35 of these projects. And so we can see right down here that we have a Gradle failure right here, and we can get the output. So now engineers at Netflix can release a new version of a library and understand who's going to break. We've been building this for a while. It's very early, and we spent a lot of time making sure that we don't break everything else. So what we discovered about building Niagara is that we've built an awesome DDoS machine against our version control system, against our binary repository system, and including our container cloud, and we've effectively brought them down a few times. So we spent a lot of time making sure that we don't do that anymore, but you can see from this chart, we run hundreds of builds a minute. And so this chart shows how many builds are completing in a 5-minute period, so each of those peaks is how many downstream builds, just downstream. And this is over the course of, I think, probably 2 days, maybe 3 days. So we run a lot of builds, and it's very peaky. So now as a publisher of a library, I'm getting feedback. I know who I break. And this is one of the huge advantages of a monorepo, is that understanding of that organizational-wide understanding. So the second element, the second pillar of our solution is built around this concept of a managed source or managed versions. And so the goal of this feature is to reduce the pain of consumption. Ideally, we can eliminate it, but I think that's overly optimistic. Really, we're focusing on reducing the pain. And so if we go back to our Niagara model, Niagara is doing a great job of understanding when someone releases a library, who's going to break. In the event that, say, someone releases a library, Niagara says everything's good, we now have a signal as to who can pick up that library and move forward in production. So you can imagine that taking this graph and just saying the consumers, the ones downstream that are going to pick this up, why doesn't Niagara just bump their version and trigger a build that actually triggers a pipeline to release their version of their application? And so that's the idea behind managed source, is that Niagara is starting to build this wealth of information if something is good or bad, a release of a library. And if we think it's good, then go ahead and start pushing teams along, and they can adopt this new version. And so it will manage their source files for them. The benefit there is that consumers of the libraries can actually start getting higher confidence that when they upgrade a library, that is actually good. But also, the idea is to really help publishers shorten the adoption cycle of their libraries. Without something kind of helping nudge your libraries along, we end up having things like quarterly deprecation cycles, in which library owners would say, every 90 days, this is the oldest version that I will support in production. Because what they end up having is they release versions constantly, but they have a wide variance of versions that are being used actively in production. And so they've had to implement process on top of all these versions to say, if you're using this version in production, you're at risk. By shortening this adoption curve, we can ideally get the adoption of a new library down to maybe ideally a month or something like that. And so you don't have to worry about deprecating old versions. And so the idea would be that we could actually achieve this goal for consumers of giving them a version that just works. So that's managed source. The third thing I want to talk about is distributed refactoring. Now, the Gradle Summit crowd has actually been lucky because you guys have heard about distributed refactoring before. Last year was our first talk around distributed refactoring. I don't see John here. I don't know if he's around here. But we talked about distributed refactoring with Gradle lint. And so you can think about that as dipping our toe into this idea of distributed refactoring. And what do I mean by that? This idea behind distributed refactoring is I want to be able to make changes to code to distribute it around multiple repositories. One of the huge advantages of a monorepo is that I could arguably grab all the source code on my machine or machines, run a search, find all the code that I want, using some type of search algorithm, and then make changes to them in a single commit. What if you could do it across all the Git repositories in a way that's distributed, and it will eventually refactor all the code over time? You can imagine, as an API owner, how do I change my API across hundreds of repos? The steps might look something like finding all the repositories that are related, finding all the API calls, refactoring all these API calls, and then issuing pull requests en masse, or some alternative refactoring method. Now, this process, we believe that this is something that would be extremely beneficial to Netflix, but it's very experimental at this phase right now. However, earlier today, John Schneider gave a talk on how he was able to refactor, I think he said, 2.5 million Java files across GitHub, and refactor them from using Guava 18 to Guava 19. So he had proved that this technology can work, and we have some open source library that does it, but we are, here at Netflix, we're in the early stages of trying to figure out how we can apply this. What's true in kind of all these cases is the technology is arguably the easy part. It's figuring out how to manage the adoption and the cultural side of this, right? So if I'm issuing emails to you every single day, you're probably not going to like this system called Niagara. But there's got to be a different way to get that signal that you're breaking people. And so figuring out that aspect, the human element of publisher feedback, managed source, or distributed refactoring is going to be the hardest challenge we have ahead of us. But we're excited about that. So when I've been vetting these ideas, talking with the team, but also talking with other companies like that in Silicon Valley, and I happened to have a conversation with Avi Bryant from Stripe. And as I talked to him about the process that the work we're doing, he said, "Hey, Mike, it sounds like you're building an eventually consistent distributed monorepo." And I said, that is a mouthful. But it is probably the most accurate depiction of kind of what we're trying to do. We really like the benefits that a monorepo provides, but we want to continue using binary integration because it makes it easier. makes it easier for people to use tools that they're familiar with and add other tools on top to augment their development experience. So the question we are asking ourselves, and you're probably asking, will this work? And the answer is, oh, we don't know. We are working hard to make progress on this, and we believe that this will alleviate pain. We obviously wouldn't be investing a whole ton of time if we didn't think this was actually going to be successful. And we know, I've heard of companies doing very similar things. I know LinkedIn has built very similar things to Astrid Niagara. And I know Amazon has something very similar as well. So there are proofs out in the world about doing binary integration at scale. And so we'll see. And that is it. We can have beer and food. Thank you.